Hi everybody, and welcome to the third attempt at our new virtual Astronomy on Tap trial. So we had two other attempts at this through Facebook Live, and large chunks of the video seemed to get lost due to network interruptions or something like that. So I'm trying a pre-recorded version now and uploading it later so that you can see the full version of what I intended to show you, and we are still going to reevaluate the best method to use moving forward. So I'm sure most of you have seen by now our announcement that we are officially postponing all future Astronomy on Tap events, or at least the live events. So we had an April event scheduled and a May event scheduled, and we don't want to just full out cancel everything, so we're just going to say they are indefinitely postponed. But in the meantime, we still do want to deliver you some cool astronomy related stuff, so we are trying to do that virtually, and we're currently exploring the best way to do that. So we appreciate your patience in staying with us, and hopefully this method works better than the other ones. So I do want to reiterate again, I know you've heard it a million times, but please wash your hands, practice safe hygiene, practice social distancing if you are able to. Don't go out if you don't need to. Don't go to large gatherings or to places where you don't need to go. Please try to protect those who may have more compromised immune systems, as this whole situation going on right now can be quite scary and quite deadly. So please just be safe and be smart about what you do. And so now we're going to move on to a brief current events. So if you've been to our events, our Astronomy on Tap live events before, this is going to be very familiar. If you have not been to anything before, then what we do with current events is we take 2 or 3 news items that you may have seen, like on a major news site about astronomy, and just go into them in a little bit more detail here. So these aren't going to be very deep dives into each topic. It's going to be very brief, but hopefully you'll learn a little bit of something and get some clarification for something you may have seen a headline for. So the first thing is spring into action. So at 4:49 a.m. on March 20th is the official start of spring, or the vernal equinox, to put it into fancy science terms. Don't know when you're going to be seeing this video. I'm currently recording it before the start of spring, but you may see it during spring, so this could be very last season news for you. So we know the spring is about to start, or just started, but what actually causes spring? So when the Earth orbits around the Sun, it orbits at its rotational axis is slightly offset from being completely perpendicular or forming a right angle to its orbital axis. Now it's offset by about 25 degrees, and this means that the amount of light that hits the northern hemisphere is different than the amount of light that hits the southern hemisphere at the same time. Now, when the rotational axis is tilted away from the Sun, that means that we have winter in the northern hemisphere and summer in the southern hemisphere. So that is what we are currently in as I am recording this video. But as we progress in our orbit, we get to a point where the light is kind of more evenly split between the northern and southern hemisphere. This is the vernal equinox, when we have spring in the northern hemisphere and then autumn in the southern hemisphere. Now, this is, since the light is equal, that means that like at the same distance above or below the horizon, above or below the equator, you will have the same length of a day in the northern and southern hemisphere, and the seasons, have a nice transitional point here. And then again, if you go 3 months later, you get to the summer, which is the opposite of the winter. Now the northern hemisphere is pointed towards the sun, southern hemisphere is pointed towards away, so you get more light on the northern hemisphere, less on the southern, and therefore it's warmer in the north and colder in the south. Hit it with a shovel. So NASA fixes a Mars lander by telling it to hit itself with a shovel. So we've sent a lot of stuff to Mars over the years. We've sent satellites, we've crashed satellites, we've sent rovers, we've sent landers and various probes. But one of those landers was called the Mars Insight lander. And one of its instrument is called the Mole. That's not its official name, but I like to call it the Mole. And that's this sort of halogen light bulb looking tube thing here sticking into the ground. So this was designed to measure the internal temperature of the Martian soil and the chemical composition and a few other things. But recently, or actually a few months ago now, it got stuck. And the reason it got stuck was because the soil was a bit clumpier than we kind of expected it to be there, and it didn't really just lift out like it was supposed to. And so this kind of puzzled the people at NASA who were working on this, because they didn't really know what to do to get it out. They didn't plan on this happening. So after months of testing and simulation and the world's leading scientists coming together, they decided the best approach is to hit it with a shovel. So I'm going to show you a little video of this. So in this GIF, you can see this very high-tech looking shovel coming down and hitting the mole. And since there's not good live video from this Mars lander, they just took a series of pictures to kind of, and that's why it's not as high of a frame rate as you might be expecting. But the shovel did come down and then hit the side of the thing. So the reason that the scientists decided to do this was, and it took so long to do it, is they needed to get the probe out to continue with other experiments, but they didn't want the fragile electronics in it to be compromised, so they tested it on Earth by building a simulated Mars Insight lander, simulated Martian soil, simulated mole, simulated shovel, and then hitting it and making sure that it didn't just completely destroy everything, like fry all of the electronics. And once they realized it would be safe, then they continued and did it, and it looks like it worked. So the last news item is, can I use GPS on the moon? So GPS is the Global Positioning System, which is something that can accurately find a location on Earth. So if you have a smartphone, then you probably have a GPS system. So if you've ever opened up like Google Maps and put in Find My Location, odds are it's using GPS tracking to find you. Now it can use an internet connection and Wi-Fi connection and through your cellular tower, but the more accurate way to do it would be through GPS. Now what this does is there's a bunch of satellites in orbit around the Earth at very precise locations, and when you take the signal from your phone, send it to the satellite, send it back to your phone, it measures the delay. And since the speed of light is constant, the further away you are from that satellite, the longer the delay. And then you measure this between 3 satellites, and you can triangulate your position very accurately, sometimes down to the centimeter, depending on what sort of technology you have access to. And while this was developed for probably more complex military applications, now it's really useful for helping you find the nearest Starbucks no matter where you are in the city. Okay, that's great and all, but what about on the moon? Can we use this on the moon? Turns out we can. But it's not as accurate, at least we think it wouldn't be as accurate as it would be on Earth. So we're planning on sending people back to the moon, at least that's what they've been saying for years now, but it looks like it's going to be happening sometime in the hopefully not too distant future. And some of the things that we're going to need to be doing once we're there are, driving around, navigating, looking for certain materials, and you don't want to get lost. Because on the moon, pretty much anywhere you go, you're going to be the first person there, so you can't use your map as accurately. You can't look for road signs or ask an alien for directions. So a GPS would come in really, really handy. And it turns out like this, the existing GPS satellites that we have around the Earth would also work if you're on the moon. Now, but since it is pretty far away, like we are closer to the satellite, the GPS satellites orbiting Earth, than those satellites are to the moon by a very large margin. So because of that, it doesn't work quite as accurately. And then particularly if you go into a crater, like if you're looking for like water ice that might be in the shadow on a crater, or if you're at high lunar latitudes. So if you think of the moon as having like a north or south pole, and you go towards one of those poles that would be at a different latitude, then you get further away from the line of sight, or you could get hidden down in a crater. So you would need some sort of relay or amplification system to remedy this. And but that could be set up for much cheaper than designing a whole nother full lunar GPS system instead of the global GPS system. I guess GPS, LPS, I don't know what they would call it, so it could be a very easy implementation, and actually would probably work as is to use GPS on the moon. Although I do suggest that if you go to make sure your phone is in airplane or spacecraft mode, because I've heard that the roaming charges are out of this world on the lunar surface. So that ends our current events for this week. Thank you everybody for watching the video. I want to remind you again, please wash your hands, stay safe, practice good hygiene and self-isolation if you are able to. We are going to be trying to bring you more virtual events in the future, and we are still exploring different avenues to do that. Like I said, maybe this will be a good avenue. We'll see. If you did like this video or did not like this video, please comment below or send us a message on Facebook, or you can email us if you prefer to do that, and let us know what you'd like to see differently or what did and did not work, so that we can make sure everything is a good experience for you. And thank you for watching. Goodbye.